Good day, everyone, and welcome back to my channel. I'm Professor Jocelyn Aguila Aglino. This is still the Mathematical Lesson Tool, Chapter 8, and I'm now going to discuss the graph part 2. Kasi yung part 1 na post na natin. And sorry to keep you waiting. This is an additional reference for you to answer the book. Okay? Okay, let's start. Now we are going to discuss the Euler circuit. What is a Euler circuit? It is a circuit that uses every edge but never uses the same edge twice. In a graph, it contains an Euler circuit called Eulerian. The annular path is a path that uses every edge once and only once. Hindi siya bumabalik o gumagamit ng ibang way. So, these two, yung Eulerian graph theorem and Eulerian path theorems, will determine if the graph contains a Euler circuit or Euler path. So, ano ba talaga ang Eulerian graph theorem? It is a connected graph is a Eulerian if and only if every vertex in a graph is of even degree. Okay. Ang Eulerian path naman, a connected graph contains an Euler path if and only if the graph has two vertices of odd degree with all other vertices in even degree. And every Eulerian path must start at one end of the vertices of the odd degree and end in the other. Example in this figure. Look at the figure 8.1 as nandyan sa slide natin. A walk of A, B, C, D. Sundan nyo lang. B, H, F, D, E, F, G, H, A is an example of Eulerian circuit in a graph if given. Okay. We can use Eulerian theorem to solve the problem involving situation modeled by graph. People in the city, for example, just sa graph na yan, people in the city were interested in finding if it is possible to walk through a city by crossing each bridge just once. Like what I have discussed to you yung una, na sabi natin, nag-start talaga tong graph na to when a scientist was advised or intuition siya to cross 7 bridges without passing twice the bridge. So now we can represent the arrangement of the land area and bridges with a graph. Let each land area be represented by a vertex and connect two vertices if there is a bridge spanning and corresponding the land area. Okay. Let's have this example. Okay. This is a Euler circuit. Now, Juan de la Cruz has just finished his 4-room brand new house. The floor plan is shown dito, is shown there. So the rooms are labeled A, B, C, and D. The outside of the house is labeled E. The openings represented the doors. Okay. Letter A, nakalagay dyan, draw a graph that models the connecting relationship of the floor plan. Use vertices to represent the rooms of and the outsides, and edges to represent the connecting door. And now, letter B, one wants to give a tour to his friend's house to a lady friend. It is possible for them to walk through every doorway exactly once. So, in which room must they begin and end the tour? Okay, paano nga naman? Oh, ito yun. Let me show you the solution. Ito yung Eulerian circuit. Okay. To walk through each doorway exactly once means that you are looking for a path that uses each door exactly once. This in, entails finding for an Euler path or Euler circuit in the preceding graph. From the graph, uh, we see that there are exactly two vertices, ano yun, B and D with a degree. By Euler path theorem, the graph has at least one Euler path but no Euler circuit. Thus, it is possible to walk through every doorway exactly once. It is not possible to begin at the end the walk in the same room. One and his friend may start at door B and end in the tour in door C. For instance, sundan niyo yung letter ha, B, E, A, B, D, C, A, E, C, E, D. In the Euler path from the graph, Euler path. Okay. Let's have the other circuit. Let's discuss another circuit. Look at this. This is a Hamiltonian circuit. Hamiltonian circuit naman finds the best way to deliver package around city or planning the best route to run errands can be modeled and solved using path and circuit that passes through each vertices exactly once. This kind of path is a circuit or called the Hamiltonian. Uh, Hamiltonian. A Hamiltonian circuit is a circuit that use each vertices of a graph exactly once. The graph that contains a Hamiltonian circuit is called the Hamiltonian. Okay, example, tingnan nyo to. Look at this example dyan sa um, tinuturo ng girl. Okay. There is no straightforward categorion to guarantee that the graph will be a Hamiltonian, but we do have the following theorems. Okay, let's have the Dirac theorems. Dirac's theorem considered a connecting graph with at least three vertices and no multiple edges. Let n be the number of vertices in the graph. If every vertex has degree of at least n over 2, then the graph must be Hamiltonian. Example, if the following graph is the following graph Hamiltonian, there are 7 vertices, diba, in the graph. So n equals 7, and every vertex has degrees of at least n over 2 or 3.5 kasi hatiin natin yung 7. Thus, by Dirac's theorem, the graph is Hamiltonian. Ano ibig sabihin nun? This means that the graph contains a circuit that visits its vertices once and return to the starting vertex without visiting any vertex twice. Tingnan niyo tong Dirac theorem does not tell us how to find the Hamiltonian circuit. It just guarantees that one exists. Okay. If the graph is does not meet the requirement of a Dirac's theorem, it is still might be a Hamiltonian considering the example given to us. Okay? Now, let's have the weighted graph. Okay. A weighted graph naman is a graph in which each edge is associated with a value called the weight. Di ba may value na yun, may number kanina, puro lang tayo letters. So the weight of edge could denote distance. Pwede rin siyang cost of travel or pwedeng ano nyo, i-relate nyo with the other number. For example, 'di ba? Ito yung 8.13 a weighted graph. This is an example of a weighted graph. The vertices represent the four cities in the Leyte Island. This is the Leyte Island. The ano 'yon? Maasin, Tacloban, and Ormoc. Okay. The weight in each edge denotes one way ng PUB fare in peso between each of the city. Yan yung pamasahe from Maasin to Tacloban, you have 250. From Tacloban to Ormoc, 150. And from Ormoc to Maasin is 150. Okay. Pwede siyang i-denote na ganon. Now, we are going to discuss another form of or force method or circuit, the brute force method, the agreed algorithm, and the edge picking algorithms. Ano ba ang dinidenote ng, ano ba yung brute force method? The optimal solution to found using the following step is one, model the problem with complete weighted graph. Okay? And then, make a list of all the possible Hamiltonian circuits. Ng pangatlo is for you to determine the sum of the weight of the edges for each of these Hamiltonian circuit. And last, the Hamiltonian circuit with the minimum sum of the weight in the optimal solution. Okay? What is now, pag-ibahin muna natin yung greedy algorithm. Okay, it is a method of finding a Hamiltonian circuit of minimal total weight in a complete weighted graph. In a graph is given by the following greedy algorithm. Number one, model the problem with a complete weighted graph. Number two, choose a vertex to start at, then travel along the connected edge that has the smallest weight. Okay. After arriving at the next vertex, travel along the vertex of a smallest weight that connects to the vertex not yet visited. Then continue this process until you have visited all vertices. Return to the starting vertex. The greedy algorithms attempt to give the circuit the minimal total weight. Although it does not always succeed, the greedy algorithm is so called because it has us choose the cheapest option of every chance we get. The next algorithm uses a different strategy. Okay, you have to choose the root first and then the vertices second. This is yung sabi ko kanina sa inyo, the other algorithm, the edge picking algorithms. Ano naman to? It is also finding a Hamiltonian circuit to minimal total weight in a complete weighted graph is given by the following edge picking algorithms. Number one, model the problem uh, with a complete weight graph. Mark the edge the smallest of the smallest weight in the graph, and then mark the edge of the next smallest weight in the graph as long as it does not complete the circuit and does not add the third mark edge to a single vertex. And then last, continue the process until you can no longer mark any edge. Then mark the final edge at that completes the Hamiltonian circuit. Consider this graph on your right, no? And then follow nyo yung follow nyo letters and numbers as we solve using the two algorithms. One is we are going to use first the greedy algorithms. Suppose we begin at vertex A. Uh, Nakita nyo na? Sundan nyo ha. The weights of the edges from vertex A are 13, 5, 4, 15, and 8. Ano yung smallest dyan? 4, di ba? 4 ang smallest doon sa edges. So, it connects A to D. Nasundan? At D, the edge with smallest weight is 2, which is D, B. It connects D and B. Then B, connect B to F. Since the edge is smallest weight, the smallest weight B is BF. Tama ba? At F na tayo. The edge with smallest weight is 7 na nagko-connect ng F and D. Since D is already been visited, choose the next smallest weight edge, FE. So, connect FE. Na-connect? Next, connect EC because the edge EC has the smallest weight, thus, whose vertex has not yet visited. Finally, all the vertices have been visited, so provided to step 4. Return to the starting vertex by connecting C to A. So, ang Hamiltonian circuit natin is A, D, B, E, C, A with a total weight of 4 plus 2 plus 5 plus 10 plus 6 plus 15 is 42. Gets? So we are going to solve now using the edge picking algorithms. First, choose the edges of the smallest weight, namely BD with the weight ng ang weight niya is 2. The edge with the next smallest weight is AD with weight 4. Choose ED. Choose ED. The next smallest weight is 5, which appears in both edges AE and FE. Choose these two edges. The next smallest weight is 6, which appears in edges B and C, then E and C. We cannot choose BC because it will add a third vertex connecting to B. So you have to choose EC. Nasusundan? Okay. We are now at step 4 to the algorithm. Any edge we choose will be a third edge to the vertex. So we choose the final edge to form the Hamiltonian circuit, which is the edge FE. So we begin to vertex A. The Hamiltonian circuit is A, D, B, F, C, E, A. Okay. In the reverse direction, An evaluated equivalent circuit is AECFBDA. The total weight for the circuit is 4 plus 2 plus 5 plus 14 plus 6 plus 5 is 36. Okay? Gets? Dali. This is much easier. The graph coloring. Dito naman sa graph coloring, madali lang siya. Okay. There is a connection between the coloring map and the graph theory. This connection has many practical application from scheduling tasks to designing computers to playing Sudoku. Okay, let's look at the figure. Tingnan nyo tong figure. Okay. How many colors do you see? Di ba tatlo? The blue, red, and green. Bakit? Pag naggumawa ka ng edges niyan, kailangan magkaibang kulay lagi. They have a different color. Pag nag-join kayo, it has to be a different color. So, a chromatic number of graph is at least a number of color needed to make a coloring. So, tatlong color yan. Okay. Paano ba gawin yan? There are steps to do the graph coloring. So, ito yon. Number one, or step one, you choose the vertex with the highest degree and color it. The highest degree naman, kanina, inahanap natin lagi sa Hamiltonian circuit, yung smallest edge. Diba dito? You have to choose the vertex with the highest degree and color it. Use the same color to color in many vertices as you can without coloring vertices joined by an edge of the same color. Number two, or step two, choose a new color and repeat what you did in step one for vertices not already colored. Okay. Isa-isa lang. Kung ano yung pinakamarami, highest number of vertex, isang color siya. Tapos, maghanap ka ulit ng hindi pa connected dun sa step 1, color mo ulit ng ibang kulay. And then, repeat step 1 until all vertices are colored. Okay. Let's have this one. Color the graph below with a given chromatic number. Dito, di ba, ang step 1, choose the vertex with the highest degree and color it. Use the same color to color as many vertices as you can without coloring vertices joined by an edge of the same color. Nakikita niyo yung number 5? Bakit 5? Kasi 5 yung nakakonect sa kanya. Okay? Pag tiningnan nyo, 5 ang nakakonect sa kanya. Itong alibaba ang hindi nakakulay, itong isang 3. So, kulayin natin. Wait, step by step tayo. Ito muna. So, color natin, color the graph below with the given chromatic number. Number 2, yung una muna, diba? Choose the new color and repeat in step 1. Ito muna kinulay natin yung 5. Diba? Yung 5, ito yung may red dito. Ang next na nilagyan natin ng red is yung number 3. Kasi hindi siya connected dun sa number 5. Okay? Alin kaya isusunod natin? Yung hindi connected sa number 5. Wala na, diba? Lahat na connected sa number 5. Bukod dito sa 3 na kinulayan natin na pangalawa, na pareho sila red. Pareho sila red kasi hindi naman sila connected. Okay. Ito naman. Kinulayan natin yung 3 sa taas ng blue at saka 3 sa baba ng blue. Connected sila sa red, pero hindi sila magiging magkapareho kapag kinuha mo yung line or edge nila. So, dapat, pag kinuha mo yung nag-color ka pa ulit, yung 3 dito, bakit sa gitna ng dalawang blue, nilagyan natin ng dalawang yellow? Kasi kapag nilagay mo dun yung blue, magiging blue to blue. Dapat hindi. Blue to yellow, yellow to blue, blue to yellow, yellow to blue, tapos red to blue, red to blue, red to yellow, then red to yellow. So, magkakaiba. So, ilan ngayon ang um, what will be our graph color? How many? 'Di ba? Tatlo. Kasi tatlong kulay. Okay. The red, blue, and yellow. So this graph coloring solve the problem such as yung scheduling problem, allocating mission to TV and radio station, study of CP or self traffic, coloring map so that two regions that share a boundary of the same color. Okay. If you have question, you can message me or comment down below if may gusto pa kayong ipa-discuss, especially for my student sa book natin. If you want something or some topics na to be discussed again, just tell me and comment down below. And thank you for watching. Hope this video will be helpful na ma-answer natin yung exercises at sa end of the book. And if you are new to my channel, please subscribe at saka pakishare kung naging useful to sa inyo so that other student will also pick something from this. Don't forget to subscribe. Thank you very much. God bless.